So this table here, we were given a bunch of n's, n equals 1, 2, 3, 4, and we get the corresponding g of n. And one way to think about it is that this function g defines a sequence where n is the term of the sequence. So for example, we could say this is the same thing as the sequence where the first term is 168, second term is 84, third term is 42, and fourth term is 21, and we keep going on and on and on. Now let's think about what type of a sequence this is. If we think of us as starting at 168, and how do we go from 168 to 84? Well, one way you could say we subtracted 84, but another way to think about it is you multiplied by 1/2. So times 1/2. And then to go from 84 to 42, you multiply by 1/2 again, times 1/2. And to go from 42 to 21, you multiply by 1/2 again. So this right over here is a geometric series. We're starting at a term, and every successive term is the previous term times what's often called the common ratio, times 1/2. So how can we write g of n? How can we define this explicitly in terms of n? And I encourage you to pause the video and think about how to do that. So so if I say g of n equals, think of a function definition that describes what we've just seen here, starting at 168 and then multiplying by 1/2 every time you add a new term. Well, one way to think about it is we start at 168 and then we're going to multiply by 1/2. We're going to multiply by 1/2 a certain number of times. So we could view the exponent as the number of times we multiply by 1/2. And how many times are we going to multiply by 1/2? The first term, we multiply by 1/2 0 times. The second term, we multiply by 1/2 1 time. Third term, we multiply by 1/2 2 times. Fourth term, we multiply by 1/2 3 times. So it seems like whatever term we're on, we're multiplying by 1/2 that term minus 1 times. And you can see that this works. If n is equal to 1, you're going to have 1 minus 1. That's just going to be 0. 1/2 to the 0 is just 1. So you're just going to get a 168. If n is 2, well, 2 minus 1, you're going to multiply by 1/2 1 time, which you see right over here. n is 3, you're going to multiply by 1/2 twice. 3 minus 2 is, or 3 minus 1 is 2. You're going to multiply by 1/2 twice, and you see that right over there. So this feels like a really nice explicit definition for this geometric series. And you could think of it in other ways. You could write this as g of n is equal to, let's see, one way you could write it as 168, and I'm just algebraically manipulating it, over 2 to the n minus 1. Another way you could think about it is, well, let's use our exponent properties a little bit. We could say g of n is equal to, let's see, 1/2 to the n minus 1. That's the same thing as 1/2. Let me write this. It's equal to 168. Let me do this in a different color. So this part right over here is the same thing as 1/2 to the n. So times 1/2 to the n times 1/2 to the negative 1. 1/2 to the negative 1. Well, 1/2 to the negative 1 is just 2. So this is times 2. So we could rewrite this whole thing as 168 times 2 is what, 336? 336. Did I do that right? 160 times 2 would be 320 plus 16, 2 times 8. So yeah, 336. And then times 1/2 to the n. Times 1/2 to the n. So these are equivalent statements. This one makes a little bit more intuitive sense. It kind of jumps out at you. You're starting at 168 and you're multiplying by 1/2 whatever term you are minus 1 times. But this is algebraically equivalent to this, to our original one. Now, can we also define g of n recursively? And I encourage you to pause the video and try to do that. And in a lot of ways, the recursive definition is a little bit more straightforward. So let's do that. I'll make the recursive function a different, I'll still stick with g of n since it's on this table right over here. G of n is equal to, so let's see, if we're going to, when n equals 1, if n is equal to 1, we're starting at 168. And if n is greater than 1 and a whole number, so if this is going to be defined over all positive integers, and whole number, what are we going to do? Well, we're going to take 1/2 and multiply it times the previous term. So it's going to be 1/2 times g of n minus 1. And you can verify that this works. If n is equal to 1, we just go right over here. It's going to be 168. G of 2 is going to be 1/2 times g of 1, which is, of course, 168. So 168 times 1/2 is 84. G of 3 is going to be 1/2 times g of 2, which it is. G of 3 is 1/2 times g of 2. So this is how we would define, this is the explicit definition of this sequence. This is a recursive function to define this sequence.